Hi everyone, welcome back to the channel. In this video, we are diving into the world of IP addressing and its classes. If you have ever wondered how computers on your internet actually find each other, then this video is just for you. Don't forget to like, subscribe and hit the bell icon so you never miss out our tech breakdown. This is the agenda of today's video, so let's get started now. First, we will understand what is IP addressing. Let's start simple. An IP address is like a digital home address for your device on a network. It is a unique number assigned to every computer, smartphone or server so data knows exactly where to go. Think of it this way, without an IP address, sending data over the internet would be like mailing a letter without writing the receiver address. It simply wouldn't know where to go. An IP address is made of 32 bits, divided into 4 sections, called octets. Each octet is written in the decimal form separated by the dots. For example, 192.168.1.1, but behind the scene it is actually binary, a series of ones and zeros like this. You might hear about the two main versions of IP addresses, IP version 4 and IP version 6. IP version 4 is the original system using 32-bit number. Think of it like having a limited number of phone numbers with a certain format. As the internet exploded, we started running out of these numbers. That is why IP version 6 comes into play. It uses 128-bit format, offering a vastly larger pool of addresses, particularly an endless supply. IP version 6 address look a bit different, using hexadecimal character as well as numbers. The IP address can be assigned in two ways, such as dynamic and static IP addresses. Most of the time, the IP address your ISP assigns to your home network is dynamic, meaning that it can change over the time. This is similar to the rendering an address. A static IP address, on the other hand, is fixed, unchanging address. These are often used by servers or devices that need to be consistently accessible. Normally, this IP address is assigned by the network administrator. After understanding the concept of IP addresses, now let's move on to discuss what are the different classes of IP address. The IP address can be divided into 5 classes, such as class A, class B, class C, class D, and class E. Let's understand every class of the IP addresses. The first we are going to take start from class A. The class A was designed for very large networks, using the first 8 bits for the network ID and the remaining 24 bits for the host ID. It ranges from 1 to 126. The default subnet mask for class A is 255.0.0.0. In binary notation, the class A IP address can be written in this way. One of the most key features of class A is that it offers limited number of networks but a massive number of hosts per the network, which is about 16 million. After understanding the concept of class A, now we are moving on to class B. It is intended for the medium to large networks. The class B uses first 16 bits for the network ID and the remaining 16 bits for host IDs. It was balanced between the number of networks and the number of hosts per network. Class B ranges from 128 to 191. The default subnet mask of class B IP addresses can be written like 255.255.0.0. Binary notation, the IP address of class B can be written in this way. One of the key features of class B is that it provides a balance between the network and host availability, which is suitable for large organizations and universities. Now we are going to understand about the class C of IP addresses, which is used for the small networks. Class C allocates the first 24 bits for the network ID and the last 8 bits for the host IDs. It ranges from 192 to 223. The default subnet mask of class C can be written as. In binary notation, the IP address of class C can be written as. One of the key features of class C is that it offers a large number of networks, but with limited number of hosts per network, making it ideal for small businesses and home networks. After understanding the class C, let's go on to discuss what is class D of IP addresses. This class is reserved for multicasting. A multicast address is used to send single data stream to the select group of multiple recipients simultaneously. This class ranges from 224 to 239. The IP address of class D in the binary notation can be written in this way. One of the most important things to remember about the class D is that it is never assigned to any individual devices. Now finally we came to discuss class E. This class is reserved for the experimental purposes, and it is not used for the public addressing on the internet. It ranges from 240 to 255.
In binary notation, the class E IP address can be written like this.
The class E IP addresses are held in the reserve for future or research use. After understanding the concept of IP address classes, now we are going to discuss what is subnet mask. A subnet mask is a number that works together with IP address to divide a network into smaller parts which are called subnets. Think of it like this. An IP address is your house number, and subnet mask is like a map that tells which part of the address belongs to the street, such as network, and which part belongs to the house, such as device or host. An IP address is 32 bits long. The subnet mask is also 32 bits. Whenever the subnet mask has 1, that part of the IP address is the network portion. But whenever it has 0, that part is the host portion.
The subnet mask of different classes of IP address are given in this diagram. The class A has first octet reserved for the network ID, while the remaining 24 bits are allocated to the host. Similarly, the class B subnet mask is consisted of 15 bits, which are used for network ID, and the remaining 15 bits are used for the host or subnets. And finally, the class C has 24 bits allocated to the network, and the last 8 bits are used for the host.
For example, IP address of 192.168.1.10, then the subnet mask can be looking like this. It means first 24 bits, which are network bits, and the last 8 bits are host bits. So the all devices in the network 192.168.1. are in the same network. Thanks for watching this video. If you guys are having any questions, then drop in the comment section. I will try my level best to answer your queries.